Hello everyone and welcome back. In this video, we're going to look at ways of displaying and describing categorical data. We will also look at exploring the relationship between two categorical variables by using a contingency table. So a frequency or count is the number of times a data value occurs in a set, and a frequency table lists all of the categories of a categorical variable along with its frequency. The relative frequencies, or proportions, are the ratio of the frequency and the total number of observations, and percentages are the relative frequencies multiplied by 100%. So the following table shows the frequency of program enrollment for Stat 251, Section A in fall 2020. So let's go through an example of calculating the relative frequencies and percentages for program enrollment. So here is the frequency table for program enrollment. To find the relative frequencies, we take each frequency in our table and divide it by the total number of students. So for the Bachelor of Science program, there are 23 students that are enrolled and a total of 45 students in the class. So to find its relative frequency, we're going to take 23 and divide it by 45, which gives us 0.51 repeating. For the Bachelor of Education, there are 11 students, and so its relative frequency would be 11 over 45, which is 0.24 repeating. For the Bachelor of Arts, there are 6 students over 45, which gives us our relative frequency of 0.13 repeating. And for Open Studies, there are 5 students, and its relative frequency would be 0.1 repeating. And the total relative frequency would be equal to 1. Now to find the percentages of each program, we're going to take each of these relative frequencies and multiply them by 100%. And so the percentage of students in the Bachelor of Science would be 51.1%. In the Bachelor of Education, we have 24.4%. In the Bachelor of Arts, there's 13.3%. And in Open Studies, there is 11.1% of students. And of course, the total percentage would be 100%. Now this table shows the frequency distribution since it lists all of the categories of our categorical variable with how frequently each category occurs. So now let's look at some of the ways we can display categorical data. So a bar chart uses bars of equal width to indicate the frequency of the categories. We label the categories along the horizontal axis and the frequencies or percentages along the vertical axis. So the following examples here show the percentage and the frequency of program enrollment from our previous example. So notice that the only difference between these two bar charts is the vertical axis label. So in one bar chart displays the frequencies and the other bar chart shows the percentages. So one thing to note about bar charts is that there are gaps between the different categories. We will see later that when we look at displaying numerical data, that there is an analogous display that may not have gaps between the different bars. However, for bar charts, there are always gaps between the different categories. Another type of display is a pie chart. A pie chart uses a circle which is sliced into pieces whose size is proportional to the frequency of the category. So the following example shows the percentages of program enrollment from the previous example, and pie charts are useful for seeing how each category fits overall. So now let's look at exploring the relationships between two categorical variables. A contingency table is a table that shows frequencies of two categorical variables at the same time. We define the joint distribution to be the overall percentages for each combination of row and column of the contingency table. So this example below shows the census counts in thousands for young adults aged 20 to 29 classified by sex and living arrangements. As our first exercise, let's find the joint distribution. So to find the joint distribution, we will take each frequency in our table and divide it by the grand total. These calculations are very much like finding the relative frequency in a frequency table. So for example, for males that are living with their parents, we would take 1020 and divide it by 4320. So we have 1020 over 4320, and if you enter this in a calculator, we would get 0.236 or 23.6%. Similarly, for females that are living with their parents, we will take 810 and divide it by 4320. So 810 over 4320 will give us 0.188 or 18.8%. And the total adults that are living with their parents, we will take 1830 and divide it by 4320. So 1830 divided by 4320 gives us 0.424 or 42.4%. And we can perform the same calculations for each of the other categories. And I'll leave it as an exercise for you to double check the calculations. So here is the complete joint distribution table, and it gives the overall percentages for each combination of row and column category. So we can interpret these percentages by saying, for example, for this value here, 23.6% of all young adults in this study are male and live with their parents. Now the margins in the table along the right column and along the bottom row gives the totals of each row and column. The frequency distribution of one of these variables in the margins is called its marginal distribution. So let's calculate the marginal distribution of living arrangements as both relative frequencies and percentages. To find the marginal distribution of living arrangements, we will focus on the totals that are given along the right column of our contingency table. We will take each frequency and divide it by the grand total. Now these calculations have actually already been done when we found the joint distribution. So for example, we will take 1830 and divide it by 4320, and that gives us 0.424, which is 42.4%. Next, when we will take 1300 and divide it by 4320, and this will give us 0.301, which is 30.1%. And in other living arrangements, we have 1190 divided by 4320, which is 0.276 or 27.6%. And if we take the grand total over the grand total, that will give us a relative frequency of 1 or 100%. So this is the marginal distribution of living arrangements. We can interpret these percentages, for example, by saying that 42.4% of all young adults in this study live with their parents. The conditional distribution is the distribution of one variable for cases that satisfy a condition on another variable. You can think of this distribution as just focusing on either one row or one column in the contingency table. So let's have a look at a couple of examples. So let's first find the conditional distribution of living arrangements for males. So for this example, our condition is males, and we want the distribution of living arrangements. Here is the first column of the contingency table, and to find the conditional distribution, we will take each frequency, but instead of dividing it by the grand total, we will divide it by just the total number of adult males, since this is our condition. So for example, we have 1020 divided by 2180, and this gives us 0.468. And next we have 530 divided by 2180, which is 0.243. And 630 divided by 2180 gives us 0.289, and 2180 over 2180 gives us 1. So this is the conditional distribution of living arrangements for males. And the way that we interpret these percentages, for example, what we could say is that 46.8% of males in this study live with their parents. So now let's find the conditional distribution of sex for those still living at home. Now this time we are focusing on a row in the contingency table, and our condition is considering only the adults that live with their parents, and we want to find the distribution of sex. So here is the row of our contingency table, counting for those that live with their parents. And similarly, we're going to take each frequency, and instead of dividing it by the grand total, we will only divide it by the total number of adults that live with their parents. So for males, we have 1020 divided by 1830, and this gives us 0.557. For females, we have 810 over 1830, which is 0.443. And 1830 over 1830 gives us 1. And so the way that we can interpret these percentages, for example, is 55.7% of adults in this study that live with their parents are male. And when the conditional distribution of one variable is the same among all categories of another, then we say that the variables are independent. And this means that there is no association between the two variables. And we can visualize the conditional distributions by using what is called segmented bar charts. And these charts show each bar as a whole and divides it proportionally into segments that correspond to the percentage in each group. So here is the segmented bar chart for the conditional distributions of living arrangements, which are grouped by sex. So the calculations that we performed in exercise 1.2.18, which is this table right here, they correspond to the bar on the left, which is the conditional distribution for males. If you were to perform similar calculations, but for females, then you will get the bar that is on the right. So now let's compare the percentages for adults that live with their parents in each group, which is the blue bars on the bottom. So what we see is that there is a larger percentage of males compared to females. And so what this suggests is that if you are male, then you are more likely to be living with your parents than females. So now let's compare the percentages for those that live as part of a couple, which are the red bars. Now in this case, what we see is that there is a larger percentage of females compared to males. And so what this suggests is that if you are female, then you are more likely to be living as part of a couple than males. And if you compare the percentages for other living arrangements, we see that they are quite similar, but perhaps a slightly larger percentage for males. Now, because the conditional distributions of living arrangements are different for males and females, then this means that there is some association between living arrangements and sex. And this means that the variables are not independent. So as our final question, what would the segmented bar chart look like if these variables were to be independent? And so I'll leave that as a question for you to think about, and this will conclude our lesson. In the next video, we will start talking about displaying and describing numerical data, and I'll see you then.